Hi, my name is John Williams, and I'm the research hydrologist with USDA Agricultural Research Service in Adams, Oregon. Today I want to share with you the results of research that agronomist Dan Long, microbiologist Kate Reardon, and I conducted between 2013 and 2018. This research was funded by the USDA ARS National Program in Sustainable Agriculture and recently published online in Field Crops Research. The name of the article that was published is Productivity and Water Use Efficiency of Intensified Dryland Cropping Systems Under Low Precipitation in Pacific Northwest. We'll provide a link to that article elsewhere. This site is in the low precipitation zone, and during the research it received 10 to 11 inches per year of precipitation in the form of rainfall, snow, and fog. Our objectives were to compare water infiltration rates, crop yield, and water use efficiency between fallow management, summer fallow, and reduced tillage fallow, and among different 2-year and 3-year cropping sequences. Crop residue going into the fallow year was chemically fallowed. Summer fallow was managed with one spring disc and a summer rod weeding. Reduced tillage fallow was managed with only one pass in July with an undercutter. We measured water infiltration rates once after final harvest to compare cumulative rotation effects. Data for crop yield and water use efficiency were collected after any one plot completed one full crop rotation. We hypothesized that infiltration rates, crop production, and crop water use efficiency would be better under reduced tillage fallow and intensified crop rotations compared to the monoculture of summer fallow winter wheat. We had 8 crop rotations that we tested: summer fallow winter wheat, reduced tillage fallow winter wheat, reduced tillage fallow winter wheat, spring barley, reduced tillage fallow winter wheat, spring Ethiopian mustard, reduced tillage fallow winter canola, spring wheat, reduced tillage fallow spring Ethiopian mustard, spring wheat, reduced tillage fallow winter canola, spring triticale, reduced tillage fallow winter triticale, spring Ethiopian mustard. In 2016, we deferred planting canola until spring due to poor summer and fall conditions. Successful production of winter canola in this region is dependent on enough soil water for germination and establishment, whether it is seeded in July or later through to mid-October. Once seeded, a combination of precipitation, temperatures, and day lengths is required to attain a growth stage capable of surviving extreme cold events through the winter without prematurely exhausting available soil water. In this region, our ability to predict how these conditions will develop is poor, and there is a moderately high to high risk of failure. Our annualized yields clustered in 2 groups. The good responding groups were summer fallow winter wheat, reduced tillage fallow winter wheat, reduced tillage fallow winter wheat spring barley, and reduced tillage fallow winter wheat spring oil. All 4 of these rotations were significantly better than the last 4 rotations we looked at. And for the most part, these are the 4 rotations that we'll focus on in the rest of the presentation. For our infiltration test, what we found was that the reduced tillage fallow had twice as fast of rates of infiltration as the summer fallow. This is significantly different and substantially different. This will make a big difference in the amount of water that you get into the soil for your crop. Limiting the infiltration test to the 4 rotations with acceptable yields shown above, reduced tillage fallow winter wheat was significantly greater than the winter wheat Ethiopian mustard. The data for measurements in winter wheat spring barley were quite variable, thus not statistically different from either reduced tillage fallow winter wheat or reduced tillage fallow winter wheat Ethiopian mustard. What seems to be apparent is that infiltration rates were not substantially improved as a result of crop diversification. Of particular note, water use efficiency of winter wheat in the reduced tillage fallow winter wheat spring barley rotation was better than either the summer fallow winter wheat or the reduced tillage fallow winter wheat. You can really see that here. And the overall crop rotation was much greater than anything else that we looked at. Finally, an interesting way of looking at water use efficiency is to give it an economic value. An extensive discussion is provided in the Field Crops research paper, and we encourage you to read it. The bottom line of that analysis is that reduced tillage winter wheat had more monetary value related to water use, followed closely by reduced tillage fallow winter wheat spring barley and reduced tillage fallow winter wheat Ethiopian mustard, with summer fallow winter wheat trailing slightly behind them. All four of those rotations were significantly better than the rest of the rotations in the study. So in conclusion, rotations with triticale and winter canola perform poorly relative to the other treatments, and we don't give these rotations a hearty endorsement. The 3-year rotations with Ethiopian mustard and spring barley performed as well as either summer fallow winter wheat or reduced tillage fallow winter wheat rotations. Dan and Kate and I wish to thank Carolyn Mell, John McCallum, Dave Robertson, and Steve Umbarger, and the many seasonal employees who provided the technical support that made this research possible. We also thank the Reese family for the many years that we were able to conduct research on their farm. This video, shot at home because of COVID-19, would not have been possible without the in-house help of two of my closest family members. Thank you.